All right, so if you take a look, like I said, some of this will be review in terms of some of the information today will be review. But if you take a look, here's kind of what this chapter, here's what you're going to see a lot of in this chapter. A lot of geometry coming back. Like I said, sine, cosine, tangent, things like that. Pythagorean theorem, 30, 60, 90. If you remember, there's some relationships there. We'll go back over those when we need them. 45, 45, 90, SOHCAHTOA, sine, cosine, tangent. Fractions. There's a lot of fractions in this chapter. We'll talk about how to work through fractions again. So that's kind of just an overview of things that you do already know that we're going to use in this chapter. Okay. So if you take a look, two ways to measure angles. Okay. Option number one that you're familiar with, degrees. Okay. That you've gone through anytime you did stuff in geometry previously. It was the sine of 30 degrees, cosine of 22 degrees, whatever it was. And what we're now going to introduce is what is called a radian. Okay. There's a second way to measure angles. And it's used in calculus a lot and further from there. So that's the second part of it. If you take a look, a couple terminology things here first. Initial side. Okay, when you look at an angle in this case, your initial side is kind of the bottom portion, and then it's opening, and wherever you end up is your terminal side. So 30 degrees, 120 degrees, whatever it is, wherever you end up, that's called the terminal side. Okay, it's the end of the angle. And then again, as always, you've got the vertex. Okay, and so if you take a look, what I had told you was, so here's an example. 1 radian is approximately 57 degrees, somewhere in there. And we'll talk about why and where that comes from. Okay, 1 radian is approximately a 57 degree angle. What we're going to look at today is we're going to try to develop what is a radian, what are we even talking about, what is this thing? So we'll get into that. Then we're going to convert back and forth between radians and degrees, because you'll do a lot of that in this chapter. And then we'll kind of finish things off from there. Okay? So first part, standard position. When we talk about standard position of an angle, all it really means is two things. That when we start putting this on an actual grid, your vertex is going to be at the origin, and the initial side is the x-axis. Okay? The start of the angle is on the positive side of the x-axis. And so here's the concept. If it opens up this direction, that's a positive degree measure. Okay? So that's approximately, let's say, a 120 degree angle. Okay? This would be, like I said, approximately 120 degrees. You could go the other way as well. Okay? Let's say I went this direction and I went around that way instead. Anybody tell me what degree measure that would be? How many degrees? 240, but because we're in the opposite direction, it's also negative. So when it opens in a positive direction like normal, it's a positive degree measure. If you would go the other direction because you end up in the same spot, this would be a negative 240 degree angle. Okay? Negative just because it's the opposite direction, and 240 because the two of these have to add up to 360 all the way around. Okay? So just a heads up that some angles will be positive, some angles will be negative. I put a couple things up here, Greek letters, different Greek letters that are used to represent angle measures, just like variables, okay, x, y, z, any of that kind of stuff. Alpha, beta, and the one you're probably going to see most often, and you saw it in geometry, was theta, okay? Tangent of theta, sine of theta, things like that. Okay, so just a heads up on those things. So your central angle, what we put in this picture, is the measure of an arc in degrees. Okay, if you kind of imagine, we're going to get into this is what is called, these next couple of chapters are what are called circular trigonometry. Because of the fact that if you think about this as a whole circle, we can also talk about like the arc length that goes with. Matter of fact, if I went through and let's say I drew a circle in. Well, this angle measure kind of matches up with that arc right there. Okay, if you remember back to geometry, 120 degree angle, that's a 120 degree arc. There's a length to that as well. All of this stuff will come back as we get into that. Here's the idea. Let me get you an idea of what this looks like. Maybe. Come on.
What's it like to learn math on Brilliant.org? Brilliant
Not
is
that.
hands-on to help you learn by doing. Learn topics from every...
All right.
Start with a circle of radius r.
Here is what a radian is. That's what this video is. So I thought it was a good video. I wanted you to see the visual. Here's what a radian actually is, okay? So when you're trying to figure out, like, well, what's 1 radian? What's 2 radians? What is that? Here's the idea.
We start with a circle of radius r. We take that radius distance and wrap it around the circle. The angle formed by that radius distance is 1 radian. Since
All
the
a radian
circumference
is.
of a circle is 2 pi r, there should be 2 pi radiuses in a circle. So halfway around the circle, we would expect 1 pi radian.
Let me
And
stop
around
for a
the
second.
entire circle-
Did you hear that part where they said circumference? You remember back to 2 pi r? Circumference 2 pi r, what that stands for is, like he said, 2 pi radiuses. 2 pi, okay? So pi is 3.14. If you double it, you get 6.28. There are 6.28 radiuses in a circle, no matter what size circle. So if I had a radius of 3, I could go 6.28 times around the circle, okay, with a radius of 3. If I had a radius of 5, same idea. So what they're getting is, if 2 pi radiuses go all the way around, that means halfway around would be pi, okay, half of that. And again, let me go back just for a second so you can kind of see it again.
The circumference of a circle is 2 pi r, there should be 2 pi radiuses in a circle. So halfway around the circle, we would expect 1 pi radian, and around the entire circle, we would expect 2 pi radians. A radian is the angle formed on a circle by using
we'll talk
an
about
arc
all this
length
stuff in a
along
second.
the circle's circumference of 1 radius. The circumference of a circle is 2 pi r. This means that there are 2 pi radiuses in a circumference, which is also to say that there are 2 pi radians in a complete circle. So, if 2 pi radians equals 360 degrees, then we have the following conversions. Pi over 180 radians is 1 degree, and 1 radian is 180 over pi degrees. So, to convert degrees to radians, multiply degrees by pi over 180.
This is kind of your
And to
conversion
convert
factor, which
radians
we'll
to
talk about. It's in the
degrees,
notes.
Multiply the radians by 180 over pi.
All right. So what I wanted you to mainly see with that was the idea of, like I said, what a radian is. It's really just taking the length of the radius and just starting to wrap it around. It's like arc length, if you will. 1 radius, whatever that angle, however far around, that's 1 radian. That is always 1 radian, which, like I said, turns out to be about 57 degrees. Okay? And you take another radius, another length, another arc length, and go again. Halfway around a circle turns out to be pi radians. 3 radiuses plus a little bit more, 0.14. Okay? All the way around is 2 pi, so 6.28 of those radiuses. Okay? And so there's your definition right there. There's your definition of a radian. It is when an arc length is equal to the length of the radius. That is what a radian is. So realistically, here's the difference between what you know and where you're headed, if you will, with a radian. You can kind of think of an angle measure as degrees, okay? And you can kind of think of a radian as arc length, if you will. Okay? There's always an angle and an arc length that go together. So you can measure it either way. That's kind of the connection between the two. Here's what this is. Okay? Here's what to explain what's going on here. Here's why this doesn't matter. If we go back to the idea of similarity in geometry. Okay? The concept that you've got the same shape, just bigger sizes. Well, if you take a radius that's this big, well, then it's only going to wrap around that part of the circle. Okay? It's going to be a smaller circle if it's a smaller radius. Then we go a little bit bigger, well, the circle's bigger. We go even bigger, the circle's going to be bigger. Ultimately, what I'm trying to get you to notice is the angle, regardless, is the same. Because the circle's bigger, it's not going to go as far around. So that's what I was trying to get at here is the bigger the radius, doesn't really matter. The angle measure, 1 radian, will always still be the same. Okay? All right, so if we take a look, here's the idea. Here's what they were talking about. So here's your conversion factor. If we go into and we talk about like there's 12 inches in a foot and we want to convert from inches to feet, that's your conversion factor. 12 inches per 1 foot. You can write that as a fraction. If you wanted to go to feet to yards, 3 feet, 1 yard, okay? This is your conversion back and forth between degrees and radians. 360 degrees, we saw in the video, is all the way around the circle. That is 2 pi radians, okay? 2 pi radians, which means halfway around the circle is 180 degrees, which means halfway around the circle is pi radians, okay? If we kind of put those two pieces together. And so therefore, here's your conversion factor. If you are in degrees and you're going to radians, and I'll show you a couple of different ones, all you have to do is multiply by pi over 180. Okay? Because pi and 180 are the same thing. Okay? Just like we just said, 12 inches per 1 foot. This is pi radians per 180 degrees. It's the same concept. Okay? It's just like if you were in a science class and you were trying to change the units. You were in chemistry and you were doing moles and all that kind of stuff, and you're trying to change the different units. That's all this is. You're changing the units from degrees to radians. Most often, by the way, just a quick heads up, and you may want to make a note of this. Most often, you know that you're in radians, or you know that a problem is given in radians if you see one of two things. Okay? Number one, when you see pi, that usually means that's an answer that's in radians. 2 pi over 3, 5 pi over 4, that kind of stuff. You'll see a pi in it. That'll give you a signal that you're in radians, okay? The second part is, if you don't see a degree, that means that you're also in radians. So they could also say like 1.5. And you might say, well, 1.5 what? Well, unless it says degrees, that means 1.5 radians, okay? So just as a heads up, 2 different ways to look at it. If you don't see a degree symbol, or if you see pi. And your other conversion factor is right here. If you're going from radians to degrees, then you just go the other way. You multiply by 180 over pi. Okay? That way the pi's will cancel and you'll be in degrees. Okay? And I'll show you that in a couple of examples here. But these are your conversion factors back and forth between the two. All right, so here we go. For example, let's take a look at a 60-degree angle. And I want to figure out what's the radian measure that goes with that. So in that case, if we take 60 degrees and we multiply it then by pi over 180, our conversion factor to get into radians. Quick heads up too, by the way, if you're trying to remember this as you go forward, easiest way to remember it is whatever you're trying to go into always goes on top. Okay? So the pi is on top because we're trying to go 2 radians. If I was trying to go degrees, then I would put the degrees on top. Okay? That's what you're always multiplying by. So in this case, if we go through and I multiply this, we can think of that as 60 over 1. Just multiply straight across. We get 60 pi over 180. And if I reduce that, what do I get?
Pi over 3.
Yeah, we get 1/3, which means this is pi over 3 radians. And there's your answer. Pi over 3 radians is 60 degrees. Okay, 60 degrees is pi over 3 radians. You'll be surprised, by the way, just as a bigger heads up, this type of stuff, radians, degrees, all this type of stuff, we're probably going to be spending about the next 2 months doing this, okay, over the course of, this is kind of the biggest part of, trigonometry is a huge part of pre-calc. This is kind of, by the time we get done with this, you'll know 60 degrees is pi over 3, just like nothing. It'll be like second nature. How about 135 degrees? Okay, same idea. If we're going to go from degrees into radians, take 135. Let's multiply it by pi over 180. Think of that as over 1. Multiply and go straight across. We've got 135 pi over 180. And what does that reduce down to if I reduce that fraction? What is it? Yeah, turns out 135 over 180 is 3/4. Okay, reduce it to 3/4. So we end up with 3 pi over 4. That's the radian measure that goes with 135 degrees. Okay, do this one on your own real quickly. Negative 270. Just put the negative, by the way, the negative doesn't change anything. It just means that we're going the opposite direction. but convert 270 degrees into radians. Let's And if we take a look, negative 270, what'd you get for an answer? Negative what? Negative what? What fraction? Yeah, negative 3 halves. Negative 3 pi over 2 is what you should get. Negative 3 pi over 2 is the idea, okay? That's what you should have. If you take that and you multiply it by pi over 180, that converts it from degrees into radians. Quick question, by the way. If negative 270 is the same as what positive angle? Anybody tell me? Now, don't worry about radians right now. Just go negative 270 would be positive how many degrees? 90. Positive 90 degrees, okay? Negative 270 is this. If you start here, that means you're going around. There's your negative 270, which means that's the same as if I just went 90 in the positive direction. You end up in the same spot, okay? So just a heads up, that's coming up too. That's got a name. That's in this lesson. All right, let's go the other way. Let's say we start with radians, and we're converting to degrees, okay? These are the ones that you're probably not familiar with. You probably don't have an idea right now of pi over 6. I have no idea what that is in degrees, okay? You will. This is one of the most common ones. So same idea. We're going to take the pi over 6. But this time I want to go 2 degrees, so we put the degrees on top. 180 over pi. Here's the nice part about when you're converting the other direction. What happens to the pi's? They cancel, which is why we no longer are in radians. The pi's are gone. Pi's cancel. We get 180 over 6. And what's 180 divided by 6? Pi over 6 is how many degrees? 30. Thank you. 30 degrees. There we go. So a 30-degree angle is 1/6 pi, if you will. Pi over 6. Okay. Do the other ones real quickly on your own. See if you convert at least the next 2. Let's talk about the next 2 here. 9 pi over 2 and then 2 radians. We'll talk about the 2 radians in a second. What I will tell you on the 2 radians, just leave it as a fraction. Just leave it as a fraction. Okay, leave the pi. All right, we ready? Ready to come back? What'd you get for 9 pi over 2? How many degrees is 9 pi over 2? What'd you get? Should be a fairly big number.
I got 810.
810? Agreed? Yep, I was going to say, it looks like we're confirming. 810 degrees is 9 pi over 2. Here's one of the reasons. One, we'll do the conversion, and then we'll try to make sure that it's understanding that why that should make some sense, hopefully. So if we take 9 pi over 2, and we multiply it by 180 over pi to convert it, again, the pi's cancel out, and now you just do the math. Multiply 9 by 180, divide it by 2, and you should get 810. Okay? So that's where that comes from. Here's why I say hopefully this will make sense. 9 over 2 is 4.5. So this is really 4.5 pi. What did we say 2 pi was? How many degrees? 360, right? 2 pi is 360 degrees. So how much would 4 pi be? Somebody said it. 720 degrees. That's 2 times around in a circle. And then you got another half a pi. That's where it's coming from. Another half of a pi is 90 degrees. Okay? And again, you'll start to get used to this. Probably not today, but you'll start to get used to this as we start working our way through it. But I just wanted you again to recognize that 9.5 pi is really 4.5. Well, 2 pi is 360. 4 pi is 720. So it's got to be a little bit bigger than 720. So that should make some sense. Here's why I said on this next one, convert 2 radians. If you have 2 radians and you are multiplying by 180 over pi, you can just leave it in terms of pi. You don't actually have to divide it out. You don't actually have to do anything. Think of this as over 1. You could just write this as 360. 360 over pi. And you can just leave it in terms of that for now, okay? Not that you couldn't divide it. You could take 360 and divide it by pi and see what you get for degrees, but you can also leave it in that format. This one, by the way, does not happen very often. It does happen where you have just 2 radians, but I would say if I put a percentage on it, 95% of the time, you're dealing with these types of problems. Pi over 6, 9 pi over 2, those types of things. Every now and then you'll get a 2 radians, 3 radians, 1.5 radians, things like that. But that doesn't happen super often, just so you know. Okay, let's keep going. So quadrants. If you take a look at the different quadrants, all I want you to recognize is this. And I'm not even sure. Did I put this in your packet? Yeah, I did. Okay. All I want you to recognize is this. This is the radian version of degrees. Okay, this is part of the reason why I printed some of this stuff off. I didn't want you to have to go through and draw all this and take all that time doing this. All I want you to understand is this. We start here, 0 degrees. Okay? If we go that far, how many degrees have we gone? 90. So pi over 2, this is really just 90 degrees. Therefore, anything between 0 and pi over 2 is between 0 and 90 degrees in terms of angle. Then we come over here into quadrant number 2. And we say this is pi. Well, we already said pi is 180 degrees. So therefore, anything between 90 and 180, anything between pi over 2 and pi, puts you in quadrant number 2. And so on, and so on, and so on. 3 pi over 2 is 270. We did that one. Okay, we did the negative version of that. But we did that one. That's all that this is explaining. This is the radian version of what you already know in terms of degrees. Okay? One of the things you're going to be doing today, and I think it's on the next slide, is given an angle, can you at least sketch what it looks like? Which quadrant you're in, that idea, okay? And right now, you're not going to be comfortable with knowing in terms of radians, so we're going to make it simple. If you're in radians and you don't know what it looks like yet, let's switch it into degrees, and then we can sketch it from there, okay, to get to that point. So for example, if you take a look, 5 pi over 6. Based on that chart, anybody tell me which quadrant you think this one is in? Just off the top of your head? See if this is making sense or not. And then I'll show you the easy way to figure it out. Anybody tell me which quadrant you think we're in? Quadrant 2? Let's take a look. Let's find out. So 5 pi over 6, if you're not sure, well, let's just convert that into degrees, and then we'll figure out where we're at. So if we take 5 pi over 6, and we're going to convert 2 degrees, we put the degrees on top, pi on the bottom, pi's cancel, and now we do the math to get the degree measured. And we end up with, you should end up with 150 degrees is what you should get. Which means if it's a 150 degree angle, what quadrant are we in? We're in the second quadrant. Yep. This is quadrant number 2. So that is the right answer. Okay? Quadrant number 2. If I were to ask you to sketch that, by the way, okay, and eventually as you work your way through, by the time you get to the test, I may ask you to go through and sketch some of these things, okay? If I were going to ask you to sketch what a 5 pi over 6 degree angle looks like, this is all I would be asking you for. I would say, you know it's about 150 degrees. Well, 150 is probably somewhere over here. You would say, there's 5 pi over 6 right there. That angle. That's all the sketch of 5 pi over 6 looks like. Okay? It's the same thing as a 150 degree angle. Okay? How we doing? Is it making sense? You doing okay? Like I said, I know this, you have not seen this before, but like I said, this is kind of your introduction. All right, let's take a look. Negative 7 pi over 4. So now we're going in the negative direction. What do you think? 1? Quadrant 1? Yes? No? Any other ideas? Let's take a look. Let's find out. Again, if we're not sure, you convert it. Okay? Take your negative 7 pi over 4. Multiply by 180 over pi. As always, the pi's cancel out. And what do we get? Negative what? Somebody do the math for me on that one. What is it? 315? So negative 315. Agreed, by the way? Anybody else confirm that for me? Yeah? Okay. So if negative 7 pi over 4 is actually negative 315 degrees, which again, if we were talking, I'll do it off to the side here. If we were talking about, where is that? Well, if I'm going negative, we're going this direction. How far is that so far? That's 270, right? Which means we got to go a little bit further than that. Negative 315 is somewhere around like right here. So we are in quadrant 1. Negative 315 degrees is actually positive what? Positive 45. It's really just a 45 degree angle, but in the opposite direction. That's the idea. So we are in quadrant number 1. That is the final answer there. Okay? We are in quadrant number 1. And you can always sketch it. That's why I'm doing that. If you're still not quite sure, even after you see negative 315, just start putting together a sketch and taking a look at what you have. Okay? Last one, 3.93 radians. How do I know that that's radians and not degrees, by the way? Yeah, you don't have any pi in it, and there's no degree symbol. So it's got to be radians. Okay, negative, or 3.93 radians. So let's switch that into degrees. 3.93. We'll do that over 1 if we will. Times 180 over pi. This one I'm going to actually divide out so that we have a number that we can work with. By the way, anybody, let's see if this makes sense. Let me ask you beforehand. Any idea what quadrant we're in? 1, 2, 3, or 4?
I'm guessing 1.
If you think. Guessing 1? 3.93 radians. 3? See some 3s? I'll tell you how you can think it through in a second versus just converting it. So if we do the multiplication, if we actually take this and we multiply and then divide by pi, what do we get for an actual answer? What is 3.93 radians? 225-ish. Okay, so around 225 degrees, which puts you where? Quadrant number 3. It is quadrant number 3. Okay, it's more than 180, but less than 270. That's quadrant number 3. Okay. Now, I was telling you could kind of think this through. What do we say halfway around the circle is in terms of radians? 180 degrees. How many radians?
1.
No.
No.
What's the radian measure for 180 degrees? Was it? 3.14. Pi. Isn't 180 degrees pi? 3.14 radians. It's a little bit bigger than 3.14. That's why when I say you can kind of think it through, that's what I was getting at is. That means we're halfway around the circle is pi radians, which is 3.14. It's a little bit bigger than that, which puts you in quadrant number 3. Okay, so just again, another way to get used to this kind of stuff. All right, last thing for today. Last concept for today as we talk about this. Coterminal angles, and we've kind of already talked about it, have the same initial and terminal sides. There's multiple ways. There is an infinite number of ways to get to the exact same angle measure. Okay? Because you could go the positive direction, you could go the negative direction, or you could go around the circle once and then another time and then another time and end in the same spot and another time and end in the same spot. You could just keep going around the circle and end up in the same spot. Okay? That's what coterminal angles are. So for example, if I went around 360, I'd be right back where I started. If I went around 720, I'm still at where same spot. If I went around another 360, same spot. You can do that for any angle that we have, okay? So here's the idea. All you need to do in order to find another coterminal angle is just subtract 2 pi, okay, or add 2 pi if you're going in the positive or the negative direction. Okay? And again, I'll show you and we'll talk about that. It is 1 revolution is 360 degrees or 2 pi. That's the idea behind it. All right, so here's the example. So if we're going to determine 2 different coterminal angles, okay? So theta, I'm giving you, is 4 pi over 3. That means this right here is 4 pi over 3 radians. Okay? We could convert that to degrees, but I'm going to leave it for now. Okay? Let's find the positive one. So here's what I'm getting at. Couldn't I just go 4 pi over 3 and then add 2 pi and still end up in the same spot? Right? We add 2 pi, I'll just go around another time. So let's take 4 pi over 3 and let's add 2 pi. Think of it as 2 pi over 1. What do we need in order to add fractions? Common denominators, which means common denominator of 3 and 1 is 3. We need to multiply top and bottom by 3. So this is really 6 pi over 3 is really what we're adding. And now combine those two together. You end up with 10 pi over 3. So 10 pi over 3 is 1 coterminal angle. That's if you went, like I said, the 4 pi over 3 plus a whole nother time around the circle. You'd end up in the exact same spot. Okay? Now the other part, we could go the other direction. Let's say I wanted a negative angle as well. I could go through and I could say, well, let's say I went this part, but then let's go back the other direction 2 pi. Rather than going another time around, let's subtract 2 pi and see what we end up with. So same exact idea. We're going to take 4 pi over 3, and I'm going to subtract. We already did the common denominator, 6 pi over 3. Which means, when we subtract, we get negative 2 pi over 3. Okay. That is what this is right here. Positive 4 pi over 3 is the same thing as negative 2 pi over 3. Okay. That's what we just found. We found the negative version of the same angle. Okay. Does that make sense to you? That those are, like I said, that's what's called coterminal angles. You're just trying to find angles that end up in the exact same spot. Okay. Add 2 pi or 360 if you're in degrees. Subtract 2 pi or 360 if you're in degrees. Okay. Try this one. See what you come up with on this one. You've got negative 2 pi over 15. I want you to determine 2 coterminal angles, one positive and one negative. So here's the idea. Like I said, and just to again give you an idea of what, to try to make sure this makes sense. If I talk in degrees for a second, just to make sure you're understanding, a 30-degree angle and a 390-degree angle are the same thing. You end up in the exact same spot. Because if you go 30 degrees and then you add 360, you're right back in the same spot, the same end, the same terminal side, the same ending spot. Okay? That's all we're doing here. We're just doing it in terms of radians. So I'm going to take the negative 2 pi over 15, and I'm going to add 2 pi. I'm going to add 360, a full circle. Okay? Which, by the way, if we're adding 2 pi over 1, we got to get a common denominator again. What would that be in terms of over 15? 30 pi over 15. That's really 2 pi as a with a common denominator. If I add those two together, we end up with 28 pi over 15. There's your positive answer. Okay, 28 pi over 15 would be the positive degree measure, or the radian measure, excuse me. And then if we take negative 2 pi over 15 and I subtract 2 pi, meaning I'm going the other way, but a full complete circle. We again will subtract 30 pi over 15, which means we end up with negative 32 pi over 15. And there's the negative version of the same thing. Okay. Like I said, day one, biggest thing that I want you to understand is hopefully just somewhat of the concept of what a radian is. Okay? The fact that it's just a radius, we'll keep working on it. And then I'd say the number one thing for today is being able to work back and forth between radians and degrees. Okay? That's kind of the main thing that we're getting at. Okay. Let's see here. I'm not even going to worry about these because I already talked about sketches and stuff. I did it on the other example, so I'm not going to really worry too much about it. But here is your assignment then for today. It is a book assignment. Again, most of the problems are very similar to what we just did. There's not a lot of work to show on any of them, other than just if you're converting back and forth between one or the other. So none of these should take you too long, hopefully, is the idea. Okay? But there's your actual assignment from this section. And the biggest suggestion I can give you is if something's not making sense in radians, change it to degrees. And then you can always change it back to radians at the end. Okay? So if it's not making sense, switch it and just change it back at the end. That's perfectly fine.